From our question given, we're to consider a plate, we're to consider what? Viscosity of a plate. Now, considering viscosity of a plate, we'll simply be given two plates and we ask to get the dynamic viscosity and also the kinematic viscosity of those plates. Now, looking at our first question here, we were given that a plate is 0.05 millimeter distance from a fixed plate, and that fixed plate moves at what? 1.2 meter per second and requires a force of 2.2 Newton per meter square. To determine this speed, find the viscosity of the fluid between the two plates in poise. If the fluid is assumed to be water, what is the kinematic viscosity? And the kinematic viscosity should be in what? Strokes. The first thing you do when you have a question like this is to identify your given parameters, because you use your given parameters to find your what? Your unknown. And what are your unknown? Your unknown is what? The first unknown is what? Your dynamic what? Viscosity. And they said your dynamic viscosity, after getting your answer, imputes that answer to be in what? Poise. That's the first thing you were given. Now, the second question you were given here was to find your what? Kinematic what? Viscosity. And your kinematic viscosity should be in what? Strokes. Are we together? So what you do is bring out your given data, use your given data to find your what? Your unknown. Are we together? Now, what are your given data? Now, from what we have here, we were given that the distance from your fixed plate to your moving plate was what? 0.05 millimeter. Now, let's bring out the graphical representation of this. So we have two plates. We have the first plate, which is always fixed, the fixed plate, and this first plate is fixed, right? So since we have this plate to be fixed, you have your velocity of your fixed plate will be what? 0. Now, we have another plate, which is always our moving plate. Now, what is the question saying? The question simply says, from your fixed plate to your moving plate, you have a distance. And what's that distance? 0.05 millimeter. So what you do is you convert 0. From our question given, we're to consider a plate, we're to consider what? Viscosity of a plate. Now, considering viscosity of a plate, we'll simply be given two plates and we ask to get the dynamic viscosity and also the kinematic viscosity of those plates. Now, looking at our first question here, we were given that a plate is 0.05 millimeter distance from a fixed plate, and that fixed plate moves at what? 1.2 meter per second and requires a force of 2.2 Newton per meter square. To determine this speed, find the viscosity of the fluid between the two plates in poise. If the fluid is assumed to be water, what is the kinematic viscosity? And the kinematic viscosity should be in what? Strokes. The first thing you do when you have a question like this is to identify your given parameters, because you use your given parameters to find your what? Your unknown. And what are your unknown? Your unknown is what? The first unknown is what? your dynamic what? Viscosity. And they said your dynamic viscosity, after getting your answer, imputes that answer to be in what? Poise. That's the first thing you were given. Now the second question you were given here was to find your what? Kinematic what? Viscosity. And your kinematic viscosity should be in what? Strokes. Are we together? So what you do is bring out your given data, use your given data to find your what? Your unknown. Are we together? Now, what are your given data? Now, from what we have here, we were given that the distance from your fixed plate to your moving plate was what? 0.05 millimeter. Now let's bring out the graphical representation of this. So we have two plates. We have the first plate, which is always fixed, the fixed plate, and this first plate is fixed, right? So since we have this plate to be fixed, you have your velocity of your fixed plate will be what? 0. Now, we have another plate, which is always our moving plate. Now, what is the question saying? The question simply says, from your fixed plate to your moving plate, you have a distance. And what's that distance? 0.05 millimeter. So what you do is you convert 0.05 millimeter to what? Meter. Are we together? Now we were given the velocity for your moving plate, and they said the velocity for your moving plate was given to be what? 1.2 millimeter per second. This was what we have here. So we were given the moving plate to be what? 1.2 meter per second, and that was the velocity that was given to us. Now, from what we have here, we can see that the distance is what? 0.05 millimeter. And you want to convert this to meter. What do? You multiply with 10 raised to the power of what? -3. So this is 0.05 times 10 raised to the power of what? -3. And this will be in what? Meter. Are we together? Now, for you to get your du here will simply be what? Du will be equal to what? The moving plate u of m, which is the moving plate, minus the fixed plate, which is what? U of what? F. And we know that the moving plate was given to be what? 1.2 meter per second, right? And you are minusing this with you are subtracting this with your value for your fixed plate, which is what? 0. And if you punch your calculator, you simply have what? 1.2 meter per what? Second. So this is the value for your what? du. Are we together? Now look up. We were also told that a force was required, which was what? 2.2 Newton per meter square. And what is this force? Looking at the unit, this unit is having what? Newton per meter square. And what is this telling you? You were given what? Shear stress. So you are giving tal to be what? Tal will be what? 2.2 Newton per meter square. What are you also given? You were asked to find your dynamic viscosity. This is your dynamic viscosity. And you're also asked to find your kinematic viscosity. Are we together? So you are asked to find your dynamic viscosity and also your what? Your kinematic viscosity. Are we together? Now, what's the first thing you are going to do? The first thing you are to do is, from what we have here, remember that our dynamic viscosity, which is what? U, is equal to what? Tal divided by du over what? dy. Where your tal is your what? Your shear what? Your tal is your shear stress, right? While your du over dy is what we call our what shear strain, or your what velocity what gradient. Now, imputing those parameters, we have that our tal here is what 2.2 meter per second, right? Divided by, what's your du? Your du was given to be what 1.2. We had our du to be what 1.2 from what we have here. So your du is what 1.2. So you have 1.2 what meter per second. This is Newton what? This is Newton per meter square, and this is what meter per second. Are we together? Now we divide this with what? What's your du? Your du here simply stands for the distance of the two plates, and the distance of the two plates is what? 0.05 times 10 raised to the power of what? -3 in meter. So we have this to be what? 0.05 times 10 raised to the power of what? -3 in meter. So what you do is, don't punch everything like this in your calculator. What you simply do is, you first punch what you have here, 1.2 divided by 0.5 times 10 raised to the power of -3. After getting your answer, then you are going to punch 2.2 divided by your answer, and you arrive at your final value for your dynamic viscosity to be what? 9.167 times 10 raised to the power of what? -5 Newton seconds per what? Meter square. So this is the normal unit we know for what? Dynamic viscosity. But for our question, from the question given, your question was given for you to find your dynamic viscosity in poise. So your unit will be in what? Poise. So what do you do? Now remember, we talked about dynamic viscosity, and we said when we are considering dynamic viscosity in poise, we know that one poise is equivalent to what? 1/10 Newton seconds per what? Meter square, which is also what? 0.1 Newton seconds per meter square. Now we're asked to find this in poise, so we can call this x. We can call this x, and x is now equal to what? 9.167 times 10 raised to the power of what? -5 Newton seconds per what? Meter square. Somebody will now ask me, why are we considering this as x? We are considering this as x because we want to get this value in what? Poise. That's why we are imputing x here. Are we together? Now, imputing x here, what will you simply do? You cross multiply your equation. If you cross multiply, you simply have 9.167 multiplying what? 1, abi, and that will give you what? 9.167 times 10 raised to the power of -5 Newton seconds per what? Meter square, multiplied by your poise here, which is poise, right? And this also will now be what? This is 1 divided by what? 10. And 1 divided by 10, 1 divided by 10, you simply have what? 0.1. So this will be what? Dividing what? This will be dividing what? 0.1 Newton seconds per what? Meter square. Such that this will go out, right? And you are left with what? Poise here, and your value for what? For your denominator to be what? 0.1. Now, if you punch your calculator, you will simply have that your x now will simply be equal to what? 9.167 times 10 raised to the power of what? -4 poise. So this will be the unit for our what? Dynamic viscosity. And the unit for your dynamic viscosity will finally be what? 9.167 times 10 raised to the power of what? -4 poise. Are we together? Now we've seen the reason why we had to put x here, such that we'll have the value to be in what? Poise. Now remember, we are not done. Why are we not done? We are asked to find your kinematic viscosity also in what? Strokes. Find your kinematic viscosity in strokes. But for you to find your kinematic viscosity, remember, you were asking your question that the fluid is assumed to be what? Water. We are assuming that the fluid is water. So what should come to your mind is density of what? Water. Density of what? Water. Now, for us to find our kinematic viscosity, we know that kinematic viscosity what? Viscosity is equal to what? Dynamic viscosity divided by what? Density. But in this case, we are taking our density here to be what? Density of what? Water. So what do? We already know dynamic viscosity. And what's the value for our dynamic viscosity? The value for our dynamic viscosity was what? 9.167, right? So we have our dynamic viscosity to be 9.167 times 10 raised to the power of what? -5 divided by what is now the density of water. Remember, from our properties of fluid mechanics, where we mentioned what? Specific dynamic, specific density, specific mass, and the rest of them. When we were considering specific gravity of a particular fluid, I told you that the density of water is a constant value that will be given to you. If you are not given the density of water as a constant value in your question, then you should take that the density of water is always what? 1000 kilogram per meter square. So we have this to be the density of water, and the density of water is what? 1000 what? Kilogram per meter square. Are we together? So what you do is you punch your calculator, 9.167 times 10 raised to the power of -5 divided by 1000, and you simply arrive at the value 9.167 times 10 raised to the power of what? -8. And what's the unit for kinematic viscosity? Meter square per what? Second. But remember, you were asked to leave your answer in what? Strokes, not meter square per second. So what do? We also know that 1 strokes is equivalent to what? 10 raised to the power of what? -4 meter per second. Recall, we know that 1 strokes is equivalent to what? 10 raised to the power of what? -4 meter square per what? Second. So if we were to calculate this to be in strokes, then we don't know the value of strokes, and we represent that value to be what? X. And we said x is equal to what? 9.167 times 10 raised to the power of what? -8 meter square per what? Second. Such that when we cross multiply, we'll finally have our answer to be in what? Strokes. Now let's cross multiply to see that. Now if you cross multiply, you are cross multiplying, this is multiplying this, and x is multiplying what we have here, right? Now if you do that, you simply have this to be 9.167 times 10 raised to the power of what? -8 meter square per what? Second. Remember, this is multiplying 1, so it still remains the same thing. But the only thing that will be added to your value here will be what? Strokes. So this will be multiplying what? Strokes. Are we together? Now, what are you left with on this other hand of your equation? On the other hand of your equation, this is what? 10 raised to the power of what? -4 meter square per what? Second, multiplied by what? X. So what you do is we divide both sides by 10 raised to the power of -4 meter square per second, and you divide here all through with what? 10 raised to the power of -4 meter square per what? Second. Now you can see that your meter square per second will cancel out meter square per second, and you are left with what? Strokes here. But remember, what you have here is what? 9.167 times what? 10 raised to the power of minus 8 divided by what? 10 raised to the power of what? Minus 4. Remember, on this side of your equation, this has cancelled out and you are left with what? Just x. So you finally have your x value will be equal to what? After doing your division, your x value will be equal to what? 9.167 times 10 raised to the power of what? Minus 4 strokes. So the value for your kinematic viscosity will simply be what? 9.167 times 10 raised to the power of what? Minus 4 strokes. So you've succeeded in calculating for your dynamic viscosity, which is in what? Poise, and your kinematic viscosity, which is in what? Strokes. Now let's take some other examples for more clarification. Now from our second question, we're actually given that the space between two parallel plates is filled with what? Oil. Each side of the plate is 720 millimeter. So basically you are given the area of the plate because each side of the plate is filled with oil at the middle, and each side of the plate is having 720 millimeter. So this is the area of the plate. The thick of the film is 15 millimeter, right? So this 15 millimeter is given to be the distance from the fixed plate to the what? To the moving plate. The upper plate moves at what? 3 meter per second, and you are given what? The velocity for your moving plate. Now look up, you're now given the force of the plate in what? Newton, not Newton per meter square. When you're not giving Newton per meter square, then you are giving what? Shear stress. Are we together? But in this case, you were just giving force to be what? 120. So it's left for you to get the formula for what? Shear stress, and solve to get your answer for what? Shear stress. Are we together? It is required to maintain the speed. Estimate dynamic viscosity of oil in what? Poise. Kinematic viscosity of oil, given that the specific gravity is what? 0.95. So you are given specific gravity. So what you do is you get the equation for your specific gravity and use that equation to calculate for the density of your oil. Are we together? Now remember, every question has a fluid that will be given to you, and also when considering questions that has to do with viscosity of plates, the first thing that should come to your mind is give the diagram of what? Your plate. Give the what? The diagram of your what? Plate. Now that should be the first thing that should come to your mind. If you want to give the graphical representation of our questions from the value we've extracted for your plate, you simply have your moving plate, right? We have our moving plate and we have our what? Fixed plate. So we have your fixed plate. Always leave your fixed plate to have this symbol. This is always telling the examiner that there is a difference between this line and this line. Now remember, they are aligned what? Side by side, parallel. They are parallel to each other. So this is your fixed plate, which is what? U of what? F, and this is what? U of what? M. Now from our question, we know that U of F, since it's fixed, is not going to have any what? Velocity. So your velocity here will be what? 0 meter per what? Second. But for your moving plate, you will simply have a velocity of what? 3 meter per second. This is what? 3 meter per second. So what you have here, you have a velocity to be what? 3 meter per what second. Now the distance from this plate down to this plate is what? 15 what? Millimeter. 15 what? Millimeter. So what you do is you convert your 15 millimeter to what? Meter. Let's convert that. So we have our dy here is given in what? 15 what? Millimeter. So what you do is you convert 15 millimeter to what? Meter, right? So if you convert that, you simply have 15 times what? 10 raised to the power of what? Minus 3 meter. So you've succeeded in converting your millimeter to what? Meter. What's the next thing you are given? You're now given that, let's get the du here. Getting the du, we know that for you to calculate for du is simply what? U of what? M minus what? U of what? F. U of moving, velocity of your moving plate, minus the velocity of what? Your fixed plate. And this will be what? 3 minus what? 0. And what you have here will be 3 meter per second. So this is your du. Are we together? Now the next thing from our question, we were given force, right? And we said the force here is what? 120. Here you impute your force in your data sheet, which is what? 120 Newton. What are we given again? We are given that the area of both plates was given to be what? 720 millimeter. Each plate was given to be 720 what? Millimeter. So the area here, we are given area, and what's area? Area is simply what? 720 millimeter times what? 720 millimeter. And that will give us what? That will simply give you what? 518,400 millimeter square. This is your area. Now remember, this area is in millimeter square. All values will be using what? SI unit. Convert millimeter square to what? Meter. If you want to convert millimeter square to meter, we'll divide by what? We are going to divide by 1000. So we are dividing this with what? 1000. And if you divide this with 1000, we'll simply arrive at what? 518.4 meter square. Are we together? Now, since we've succeeded in getting the area, we already know force. But remember, from our elementary physics, we know that when we are considering shear stress, which is tal, is equal to what? Force over what? Area. Right? So if you have force over area to be shear stress, we'll simply have that the value for your tal, will simply be what? What's your force? Your force is in Newton, 120 divided by 518.4. So you simply punch your calculator and you arrive at the value for your shear stress, which is what? 0.2315 Newton per what? Meter cube. Newton per meter what? Square. Now, observe your values. Always check your values with your calculator. From what I have here, I have what? 0.2315 Newton per meter what? Square. So this is the unit for your what? Your shear stress. Are we together? Now, since we've gotten the shear stress, what parameter are we to get again? I think we've gotten all parameters. Now remember, recall that you were given your oil, your fluid here. Your fluid is what? Oil. Always tell the examiner the fluid that you were given. Sometimes they will assume you don't know the question that you are answering. You are just using ChatGPT to answer your questions in exam. So instead of using ChatGPT to answer the questions, prove them wrong by putting all parameters in your data sheet, so they will know that, oh, you know what you are doing. Now the fluid you were given here was what? Oil. You were given the fluid to be what? Oil, right? So the examiner looking at your data sheet and is seeing that, you even know the fluid that was given to you, then you know what you are doing. Are we together? Now, since we've gotten all parameters, our interest is always to calculate for your dynamic and your kinematic. Are we together? Now, to calculate for your dynamic, we know that dynamic is what? Tal divided by what? Du over what? Dy. Are we together? We already know what's tal, we already know what's du, and we already know what's what? Dy. So we impute those values into this formula and get our what? Dynamic what? Viscosity. Now, if you impute those values, you simply have, what's your tal? Your tal is 0.2315 Newton per meter square. So what you have here will be what? 0.2315, right? Newton per what? Meter square. Are we together? What will be the next value you are going to arrive? What will be the next value you are going to get? So next value is to get what is your du, right? Now, from what we have here, we know that our du is what? Our du was given to be what? 3 meter per second. So you have your du to be what? 3 meter per what? Second, divided by, what's your y is 15. 15 times 10 raised to the power of minus 3 meter. So what you simply do in your calculator, you first punch 3 divided by 15 times 10 raised to the power of minus 3. After getting your value, then you now punch 0.2315 divided by the answer you got. And that will give us what? And that will give us 0.00116. So this will give us 0.00116 Newton seconds per what? Meter square. Are we asked to leave our answer in pause? Yes, we're asked to leave our answer in what? Poise. So leaving your answer in poise, that is telling you that, recall that we know that 1 poise is equal to what? 1 divided by what? 10 Newton seconds per meter square. Now, in essence, we are to get this value in poise, and we don't know what is this value in poise. So we represent that value to be what? X. And we know that x is equal to what? Equivalent to 0.00116 Newton seconds per what? Meter square. So what we do is we cross multiply. Cross multiplying, we'll simply have that your x will now be equal to 0.00116 Newton seconds per what? Meter square multiplied by 1. If you still multiply by 1, it still remains the same thing, but what will be added will be what? Poise. So you have poise here, right? Now remember, if x is multiplying this, you'll be left with x and this, abi? So what you do is, to make x subject, you divide both sides by what? 1 divided by what? 10, which is 0.1. So this will be 0.1 Newton seconds per meter square. Now, Newton seconds per meter square, we cancel out Newton seconds per meter square, and you're left with what? Poise. Now remember, you have a value to punch in your calculator. If you punch this value in your calculator, that will simply give you what? 0.0116, and the unit will be in what? Poise. So this will be your dynamic what? Viscosity. Now remember, since we are given that our dynamic viscosity to be in poise, leave your kinematic viscosity in what? Centistroke, not what? Stroke. So what you are going to do is, when you are calculating for your kinematic viscosity, you first get your answer to be in what? Meter square per what? Second. Convert your meter square per second to what? Strokes. Convert your strokes now to what? Centi strokes. Are we together? It's very simple. Now let's do that. For your kinematic viscosity, remember, when we are considering kinematic viscosity, we know that kinematic viscosity, it is the ratio of what? Dynamic viscosity with what? Density. Now, but what you are given here will now be what? Density of what? Oil. Density of oil. Now recall, from your question, you were given that you have a specific gravity. Now, what is now the specific gravity you are given? You are given that the specific gravity was given to be what? 0.9. So you tell your examiner that you were also given, recall that specific gravity was given to be what? 0.95. Do we know the density of oil? No, we don't know the value for your density of oil. Now it's left for you to calculate for the density of what? Oil. Now recall, when we talked about the properties of what? Fluid mechanics, we made mention of specific gravity as one of the property. And I said for you to calculate for specific gravity of a particular fluid, what you do is you get the specific gravity is equal to what? The density of that fluid with respect to the what? The specific weight of water. That's the formula we are to use. Now, recall that specific gravity of a particular fluid, but remember the fluid you are given here was what? Oil. So you have to get the specific gravity of oil, which was already given to you to be what? 0.95. So the specific gravity will now be equal to what? Density of oil, right? Divided by the specific weight of what? Water. So you have the specific weight of water. And we know that the specific weight of water is always what? 1,000 kilogram per meter square. Are we together? Now, what we have here will be what? 0.95, and this will be equal to density of what? Oil, which we don't know, and this will be what? The weight of water. And we know that the weight of water is what? 1,000 kilogram per meter square. Now, what do? For you to get your density of oil, you make density of oil subject by cross multiplying, and you simply have that density of oil will now be equal to 1,000 multiplied by what? 0.95, and that will give you what? 940. So we have 940 kilogram per meter square. So this will be the value for your density of oil. So what you do is you impute this value into your equation that says what? Kinematic viscosity is the product of what? Dynamic viscosity divided by what? Density of oil, which is what? 940 kilogram per meter square. Are we together? So you have that your kinematic viscosity will now be equal to, what is now your dynamic viscosity? Your dynamic viscosity was given to be what? 0.00116. So you have your dynamic viscosity, which is what? Your dynamic viscosity, which is 0.00116 Newton seconds per meter square, divided by 940 kilogram per what? Meter square. And what will you get? You will simply arrive at the answer to be 1.2340. 2340. Always confirm your values. Always confirm your values. From what I have here, I simply have my answer. I simply have that my answer here is 1.234640 times 10 raised to the power of what? -6. And what's the unit? Meter square per what? Second. Now remember, you are not done. You are to convert your meter square per second to what? Strokes. Converting to strokes, because you cannot just convert this value to what? Centistrokes. You need to convert it to strokes first before converting it to what? Centistrokes. So to convert it to strokes, you recall that we know that 1 stroke is equivalent to 10 raised to the power of what? -4 meters square per what? Second. So we have that x, since we don't know the value in strokes, we call it x, and x is equivalent to what? 1.234 times 10 raised to the power of minus 6 meter square per what? Second. So what you do is you cross multiply and you get your answer, which is what? Your x here, to be what? 1.234 times 10 raised to the power of minus 6, and this will be what? Meter square per second multiplied by strokes, and this will be divided by 10 raised to the power of what? Minus 4 meter square per second, right? So what you have is meter square per second will be cancelling meter square per second, right? So if meter square per second is cancelling meter square per second, you are just left with your strokes. So your strokes now will now be 1.234 times 10 raised to the power of minus 6 divided by 10 raised to the power of what? Minus 4. And you will simply arrive at a certain value to be what? 0.0123. So you have 0.0123 strokes. Now drop your correct answers on your comment section. Drop all the correct answers on your comment section. If the answers here are very correct, then put a thumbs up on the comment section. Now remember, we're to convert this to centistrokes. Converting this is already in strokes. So we are converting this to centistrokes. Now to convert any value to centistrokes, we know that 1 centistroke is equivalent to what? 1000 raised to the power of minus 1 strokes. So for you to convert your strokes here to centistrokes, we have that x is equal to what? 0.0123 strokes. So what you do is you cross multiply and you get your answer in strokes. Now let's go to a new page. If you cross multiply, you simply have that your kinematic viscosity in centistroke will now be equivalent to what? 1.23. Remember, what you have there will be what? 0.0123 strokes multiplied by what? Centistrokes. And this will be dividing what? Remember, this will be dividing 100 minus 1 strokes. So strokes will cancel out strokes and you're left with what? Centistrokes. So what you do is you punch your calculator, 0.0123 divided by what? 100 minus 1, and you have that your kinematic viscosity to be in what? 1.2340 centistrokes. So this is the final value for your what? Your kinematic viscosity. Is it not very simple? It's very simple. What you do is you know your steps, you apply your steps, and you get your what? Your final answer. Now let's take an exam question. Looking at this question, you can see that this is an exam question. So it's practically an exam question. Now from what we were given here, we were asked that the space between two plates is what? 5 millimeter apart. And that plate is filled with what? An engine oil of what? 0.9 watts specific gravity. So you can see that this place is the space where your oil is being filled, and the distance from your fixed plate to your moving plate is what? 5 millimeter. Are we together? Now you were also given a hint of what? You're asked that shear stress is equal to what? Dynamic viscosity plus what? Velocity multiplied by what? Velocity gradient. Now remember, this is your rule for what? Newtonian fluid. So if you've gone through the videos for Newtonian fluids, your non-Newtonian fluids, you should be familiar with what this equation. Are we together? So from this equation, you can make your U here, which is dynamic viscosity, to stand alone by dividing both sides by your what? Your velocity what? Gradient. Are we together? Now, from what we have here, let's bring out our data sheets. From our question, we'll simply have our data. The first thing we have there is for you to consider the distance of your fixed plate and your what? Moving plate. The distance here is what? 5, right? So we're given 5 millimeter. So you are to convert that 5 millimeter to what? Meter. So you have dy here, and dy is given to be 5 millimeter. So you convert this 5 times what? 10 raised to the power of minus 3 meter. So this is in what? Meter. Now the next thing you are to consider is your moving plate and your what? Your fixed plate. From your moving plate, you have that your moving plate is having a velocity of what?